Okay, practice number 9. We've been saving the best for last. This is a challenging one, and there's 2 parts, and both parts are challenging. So let's jump into it. Practice number 9 says, in a medical study, the mean systolic blood pressure is 120, and the standard deviation is 8. Okay, so maybe you've had your blood pressure taken at some point or another. So there's the systolic number and the diastolic, if I'm remembering correctly. I'm not a medical person, clearly. I believe the systolic is the first number. It's the larger number on top. So they say you're 120 over 80 or something. So your systolic is the first number that they give you, the bigger number. Okay. The standard deviation of systolic blood pressure in this study was 8 from all the people who they measured. So what does it ask for in part A? What systolic blood pressure reading would put someone in the top 10% of the population? And by the way, if you were in the top 10% for systolic blood pressure, that is not a good thing. That you would have high blood pressure for sure if you're in the top 10%. Okay. Now let's take a look at what they're giving us. What systolic blood pressure reading would put someone in the top 10%? What have they done? They're giving us a percentage. Okay, and if they're giving us a percentage, that means we're going to have to work backwards at some point. We're going to use our table of z-scores in reverse. If they ever give you a percentage, it means to answer whatever question they're asking, you're going to have to work backwards. So let's put all the pieces together. So we're still going to use our z-score formula here. They tell us the mean, right? So we know mu is the 120. They tell us the standard deviation, sigma, is 8. And then they give us a percentage. We use the percentage to find the z-score. So it's x that we're looking for here. What data value would put somebody in the top 10%? So what x value serves as like the cutoff for the top 10%? Let me explain that a little bit further with a graph. Okay, let's recap our information. So we got mu equals 120, sigma equals 8. We're going to use our formula. I've been talking about that. So here's a graph I find very, very helpful to wrap your head around what they're giving you and what you need to do. So draw yourself a quick bell curve like that. Draw that line underneath. So they told us the mean is 120, so that's right in the middle. And they said, okay, what x value cuts off the top 10%? So there's some x value up here. There's some systolic blood pressure reading there that, serves to designate the top 10. So anything above that is in the top 10%. So our goal, to answer the question, we need to figure out that x value. How are we going to do it? Well, we know 2 pieces to the puzzle, right? We know mu, we know sigma. If we can find z, then we can solve this thing for the x, and we got it. And we'll use the 10% to do that. Okay, but this is the top 10%. But that's not how the z-table works, right? The z-table always tells you the probability less than. So if there's 10% above, what percentage is less than? And of course, it's 90%, and you can probably see my work there that I had tried to erase. But yeah, if this is cutting off 10% above, then, well, there must be 90% below. So we can think to ourselves, okay, what's the probability that what's the z-score that would designate the 90%? So the probability that z is less than z equals 0.9. And there's kind of a complement happening there, right? Because we could say probability that z is greater than z equals 0.1, but that's equivalent to saying z less than z equals 0.9. And at this point, we're going to use our table backwards. We're going to try and find 0.9. Okay. Now, what you'll realize pretty quickly is that the probabilities that you find in that z table, they're not pretty, right? Nothing with the normal distribution as far as like the numbers and the probabilities go. You rarely get these nice, clean, like round sort of numbers. They're these awkward decimals, and we round them to 4 places. So we're not going to find exactly 0.9 in our table. So my note here, and I'm trying to cover up, what we're actually going to find the closest probability to it. Get as close as you can to 0.9. And remember, we're working backwards. So, okay, let's go for it. So should we be using the positive z-scores or the negative z-scores? We need the positive z-scores because we're in the upper 50%. So we'll go to the positive z-scores, and we're going to try and find 0.9. It's not going to be there, so we're going to get as close as we can. And it looks like it's somewhere kind of right in the midst here. Okay, so I see like 0.9099, but we can get closer, 0.9082. And as you look, hey, there's 0.9015 and 0.8997. Okay, which one is closer to 0.9? And it's this one, right? 0.8997. And interestingly enough, a lot of students, they end up picking 0.9015. 0.8997 is closer, right? Like it can be less than 0.9. You're getting as close as you can to 0.9. And then we're just going to use that z-score. So what is that? 1.28. 0.8997. So I've got that right here. The closest that we could use in the table, and you don't really have to write this, just make sure you get the z-score correct, but just for our lecture, the closest probability we could find was 0.8997, and that was z equals 1.28. Perfect. We got the z. This is great. Let's plug it all in. Find the x value for this z-score. So 1.28 equals x minus 120 over 8, and we solve for x. We're going to multiply the 8 over here, which would be 10.24 equals x minus 120. We're going to add the 120, and we're going to get 130.24 equals x. So in other words, the x value here that cuts off the top 10% is 130.24. If that's your systolic blood pressure or above, then you are in the top 10%. Not a good thing in this case. So again, it's like that working backwards. Here they gave us a more than, right? The top 10%. So we had to use a complement before we went to the z-table. And then the z-table, we couldn't even find that number exactly, so we had to get close, right? Some new elements here for sure. Okay, let's go to part B. A researcher wishes to select people in the middle 40% of the population based on systolic blood pressure. Okay, so maybe this researcher, they're looking to do a study, and they just want to look at people who have a healthy systolic blood pressure. So they're picking the middle 40%. So not too high, not too low. Find the upper and lower readings that would qualify someone to participate in this study. Okay, so part B is very similar to part A, but there's a little bit more going on. So for one, we have the same values for mu and sigma, right? And again, they give us a percentage. So that means that we're going to use the table backwards. If you see a percentage in that problem, it's like they're telling you the probability, and you're going to have to work backwards. So if they give us mu and sigma and a percentage, that means we'll be able to get z. So we're looking for x. Here, though, we're actually going to look for two different x values. They want the upper and lower readings. Okay, so let me give you a graph. I find especially in part A, I think it was huge to have that graph. In part B, I don't see how anybody can do this one without a graph. When they say the middle 40%, they mean the 40% that is symmetric about the mean. Okay, so we got 120 at the middle. The 40% like straddles the bell curve. Okay? So that means we're going 20% this direction and 20% this direction. This is the upper reading for the middle 40%. This is the lower reading for the middle 40%. So we want to find where these two x values are, because that would tell us, okay, anybody between them is in the middle 40%, and they would qualify to be in this study. So we're going to have to find two different z-scores and use our formula backwards twice, one for the upper, one for the lower. But hey, if you can do it once, you can do it twice, right? It's just a little bit more work. And you can see, wow, I could certainly understand, this is real life statistics, right? Hey, I want to do a study on the middle 40%. Okay, sit down and crunch your numbers and figure out what readings that would mean for all the people that were in this study you did, right? Okay, let's get to it. I want to do a little bit more with my drawing here. Before we go and find the z-scores for these, we need to know what probabilities we're going to look up in the table, right? So here's what I've done. What do I mean by 30%, 50%, 70%? That's the percentage below each one of these, because that's what the table tells us. Let's start with the middle. I think that's the best place to describe what's happening here. So at the mean, there is 50% below. Right? 50% of the data is to the left. There's also 50% above, but we always do probabilities less than. So there's 50% of the data is below 120. So if we move 20% this direction, how much is below that x? Well, it'd have to be 30%, right? There's 30% of the data below, because the other 20% is here. And if we move up 20% to the upper x value, well, then there's got to be 70% below. Okay, because there was 50 and we added another 20, so there's 70% below this way. We could recognize there's also 30% of the data here in the upper portion, but we don't really care about that. Okay, so recognizing these probabilities or these percentages below, really we want the 30% and the 70% to find the z-scores that go with our x values. Okay, so let's start with the lower bound, the lower reading. We know there's 30% of the data less than that. So here's what we're going to do. We're going to set up probability that z is less than z equals 0.3 for the 30%. And we're going to use our table backwards. Now we're not going to find 0.3 exactly. So we're going to find the closest thing that we can, or the nearest. And that's going to be fine. Notice this will be a negative z-score because it's in the lower 50%, so I'll go to the negative side. And we're going to try and find 0.3, or the closest thing we can. Okay, so the 0.0, okay, wow, 0.1, 0.2, okay, we're getting closer. There's 0.2981, and oh, well, it looks like it's between these, 0.2981 and 0.3015. Which of those is closer to 0.3? And it turns out in this case, the closer one to 0.3 is this one right here, 0.3051 is as close as we can get. Okay, well, what z-score is that? It's negative 0.52. As close as we can get to 0.3. So the z-score that goes with this x value would be negative 0.52. Okay, we'll come back to that and we're going to solve for that x value in a moment. I'm going to move on. While we're talking about z-scores and using our table, let's do it for the upper z-score. And we recognized the amount of probability below that x value is 0.7. So probability that x is less than z equals 0.7. Same idea, we're going to use our table backwards. We're just going to get as close as we can. This would be a positive z-score. So how close can we get to 0.7? Let's see, these are 0.9s, 0.8, 0.7, okay. Okay, oh, okay, right in here. So we got 0.7019, and on the other side we got 0.6985. Which one is closer? It's this one, right? 0.6985 is closer than 0.7019. What's the z-score there? 0.52. Hey, you notice something? .5. It's the positive version of our other z-score. Is that a coincidence? No, that is not a coincidence. Why? Because it's symmetrical. At the middle, that's z equals 0. So if you move 20% this way, or 20% this way, it should be the same distance as far as z-scores go. So if this is negative 0.52, this will be positive 0.52 because it's symmetrical around z equals 0. So in the future, if you're doing a problem like this and you find one of them, then you can immediately know the other one by either removing or adding a negative sign. One, if it's a middle percentage like that, one will be positive, one will be negative, but the number, if you will, is the same. The distance from the center is the same. It's a good idea. Remember what a z-score even represents, right? The number of standard deviations. So moving this way 20% for this data would be you're moving 0.52 standard deviations this way, and you're moving 0.52 standard deviations that way. That's what the z-score is telling you. So if you're moving the same percentage in both directions, then you're moving the same number of standard deviations, and so one positive, one negative. Okay. I think you get it. All right, we're going to use our z-scores now to solve for these x's, and I've kind of done this side by side. So find the x values for these z-scores. So we're going to set them up. Here's the lower with the negative 0.52, and it equals x minus 120 over 8. And here's the upper, positive 0.52, and it also equals x minus 120 over 8. So we're going to get our lower x value and our upper x value. And I went ahead and looks like I'm not showing that extra step in the middle, but what we're going to do, we're going to multiply by 8, and then we're going to add 120. And I got 115.84 equals x. Same idea over here. We're going to multiply by 8, and then we're going to add the 120, and that gives 124.16 equals x. So there's our lower reading, and there's our upper reading for the middle 40% of the data. And notice, even, just to wrap up, these numbers are perfectly symmetrical about the 120. They're the same distance to the left and to the right. They're both 4.16 this way, 4.16 that way, just kind of a reflection. And they should be, right? Because it's all symmetrical. Okay, that was a long problem. That's about as challenging as these get. So if you understood everything in number 9, great job. Now it's Always a different story when you have to do the problem, of course. But if you understood everything here, then you're doing very well. This is as tough as they get for sure. If you didn't, obviously you can go back and watch this again, or try one out on your own and see how far you can get. Okay, that's all I'll say. We got one last idea in this chapter next.